Let's talk about precipitates. So a precipitate is a solid, and as you can see my beaker, I drew some solid particles underneath here. So if the A, B are together and it's a solid, then when they dissolve it becomes A plus and B minus aqueous, and you won't be able to see that. Here's a picture of a precipitate. Here's this white solid there, that's AgCl. That is a precipitate, it's a solid. Okay? So the question is, how do you know if a precipitate will form? How do you know if you'll make a solid? Well, if you've put too much in there, that means you've made a saturated solution, right? So remember, Q is at any point of the reaction you may or you may not be at equilibrium. If Q equals K, that means you're at equilibrium and the solution is saturated. And this is what a saturated solution looks like. There's some solid in the bottom and there's aqueous ions going back and forth. Okay. If Q is less than K, that means, hey, you can dissolve more in there and you won't see anything in the beaker. It just looks like water and you won't be able to see a solid. There will be no precipitate. But if Q is greater than K, that means you have so much more than what you can dissolve, then it will precipitate. We're going to do some practice problems. When you're solving the problems, here are some steps. They're going to give you the number of ions in there. I'm going to ask you to reverse the equation. I'll show you what that means. Reverse it. I'm going to ask you to find molarity, and I'm going to ask you to add the total volume. To get molarity, you're going to find Q and then compare that Q to KSP. So let me show you what I mean. So it says, will a precipitate form when you add 0.1 liters of 8 molar of lead nitrate? And here notice that nitrate is a spectator ion. I don't care about it. I only care about lead. Okay, so this is going to be +2. Wait, this is -1 each. And there are 2 of them, so this is lead is +2. Lead nitrate is fully soluble. Okay, so you're going to get all of that in the form of Pb +2. Remember, potassium, sodium, ammonium salts, wherever they may be, when asked about the nitrates, the answer is always clear. They each and all are soluble. It's all we want to hear. So all of that will dissolve. So I'm going to ignore the nitrates. And you have 0.10 liters of that. And you have 8.0 E -3 molar of that. And you're adding it to some Na2SO4 minus. Okay. So this is going to be the spectator ion, the +1 of the sodium, and you're going to have some -2s in there, so I'm just going to add the SO4 -2. Okay? And so this is 0.40 liters, and this is 5.0 E -3. Okay? So when you put these together, you're going to make PbSO4. And they're asking if you will make a solid. PbSO4, if you look at the reference chart, lead 2 sulfate, right here, is not very soluble. It's 10 to the -7. 6.3 E -7, that's KSP. Let's write that down. We'll need that. 6.3 E -7. That is the KSP. Okay? So the first thing I'm going to ask you is, according to this, is to reverse the equation. Because these KSPs are showing how much PbSO4 dissolves, I'm going to ask you to flip the equation. So Pb +2 plus SO4 -2. Okay, that's the first step. The next thing you're going to do is find molarity. Okay, so you're going to multiply these together to get moles. So it'll be 0.1 liters times 8.0 E -3. That's molarity, so moles over liters. The L's will cancel and you will get 0.0008 moles of Pb +2. Do the same thing on this side. I'm going to make my pen a little bit thinner here. So 0.40 liters times 5.0 e negative 3 moles over liters. Again, that's molarity. And you're going to get 0.002 moles. Okay? Because the equilibrium expression has molarity in it, you have to divide it by liters. And because you mix them together, you have to add this and this together to make 0.5 liters, okay? Now you have molarity. So that divided by that is 0.0016, and these two divided is 0.004. Okay, so the equilibrium expression, if you don't know if you're at equilibrium yet, you're going to solve for Q. Q is going to be equal to Pb plus 2 concentration times SO4 minus 2 concentration. It's equal to 0.0016 times 0.004. Remember, the brackets means molarity, therefore I used molarity. Okay, so Q is going to be equal to 6.4 e negative 6. Okay, so remember that Q is equal to products over reactants. This is a 1. Okay, now I'm going to compare that to K. What is K equal to? We looked that up earlier, 6.3 e negative 7. 6.3 e negative 7. Products over reactants. Okay, so what can you say about your products in your Q? You have too much ions in there, don't you? Compared to this number is bigger. If you have too much ions, you will get a precipitate. PPT is short for precipitate. So what will happen? If you drop these two solutions in water, you're going to get a beaker with some solid particles in the bottom. And they're going to be PbSO4s. So yes, you will get a precipitate. Okay? This practice exercise, go ahead and try it yourself. Pause the video. Okay, so here's my equation. I have CaNO3. I'm going to ignore the NO3 again. So I have plus 2 pretty much. And I have NaF. I'm going to ignore the Na. So I just have F. Okay, so I'm going to go ahead and write the equation. I'm going to mix F minus, right? Plus Ca plus 2. And I'm going to make CaF2. Oh, there should be 2 of these, right? It says, will you form a precipitate when you mix these ions together? I know they're in ions because sodium soluble and nitrate soluble. First thing I do is flip the equation. CaF2, arrow 2F minus, plus Ca plus 2. Okay, the givens are, we have F minus 0.05 liters, and you have 0.02 molar. This is 0.01 liters given there. And this is 0.01 molar. Okay, multiplying those two, I'm going to get 0.001 moles. Multiplying these two, I'm going to get 0.0001 moles. Divide both of them by the total volume, which is 0.06 liters. 0.06 liters. 0.06 liters. Now I have my molarity as 0.0167, 0.0167. Ooh, I have equal amounts. Interesting. Oh no, this is 0.00167. Okay. What's this? Okay. Oops, wait. 0.001 divided by 0.06 is 0.0167. 0.0001 divided by 0.06 is 0.00167. There you go. Okay, so Q is equal to F minus squared, molarity squared, times Ca plus 2. I don't know how I mix those up. So it's F minus is 0.0167. Square it, and then 0.00167 equals 4.6 e negative 7, which is too big compared to 3.9 e negative 11. That means you have too much ions. So that means you will get a precipitate. A solution contains 1.0 molar Ag plus and 2.0 molar Pb plus 2. So I'm going to go ahead and draw a beaker. It's going to be kind of wide just to show you what's happening here. You have Ag plus, and you also have some Pb plus 2. Okay? When Cl minus is added to the solution, so you're adding Cl minus here, Cl minus there. And the KSP, it'll obviously make AgCl, right? And the KSP is 1.8 e negative 10. That means that doesn't want to dissolve. It's going to become a solid. So this is 1.8 e negative 10 is the KSP for this one. And then this one, KSP is P 1.7 e negative 5. Okay, let's think about this. This one is smaller. What does that mean to you? Which means AgCl won't dissolve, right? Or it doesn't want to dissolve. That's too much to write, so I'll just say it won't dissolve. So Ag plus and Cl minus are really attracted, right? Which means it doesn't take much Cl minus to make it solidify or precipitate. You need very little Cl minus to make AgCl solid. Not much is needed, they'll turn into a white solid. And this one, compared to this one, you don't need as much. No, you need very little. This one you'll need more because you can dissolve more of it. Okay, so here's the question. What concentration of Cl minus, so how much of this, question mark, do you need to precipitate this salt and to precipitate this salt? To make AgCl, how much Cl minus do you need to make AgCl, and how much Cl minus do you need to make PbCl2? Okay, so you're going to have two equations. First is AgCl. You have to think about the equilibrium of that, Ag plus Cl minus. So the KSP of this is Ag plus and Cl minus, which is 1.8 e negative 10, is equal to Ag plus is right here. They gave it to you. 1.0 e negative 2 molar. So if you want to know how much Cl minus you have, all you have to do is solve for it. So that is molarity, by the way. So to make this precipitate, you're going to need 1.8 e negative 8 molar of Cl minus. And what that is what you need. It's needed to precipitate out AgCl. Okay? So now you have to do the same thing. How much do you need to precipitate Pb plus 2 out? So Pb Cl2, Pb plus 2, and 2Cl minus. KSP is 1.7 e negative 5 is equal to, Cl minus is 2.0 e negative, wait, no, Pb is 2.0 e negative 2. And this is going to be squared, Cl minus squared. Okay, so you're going to solve for Cl minus, and you're going to find the number 2.9 e negative 2. Okay, so this is needed to precipitate all of it out. Precipitate all up. To precipitate PbCl2. To make PbCl2. Okay, so what's the question? I forgot. What concentration of Cl minus is necessary to begin the precipitation? You answer that right here. This is how much Cl minus you need to precipitate AgCl, and this is how much Cl minus you need to precipitate PbCl2. Which salt precipitates first? Well, you don't need that much of this one, right? You need very little Cl minus, so which means AgCl will come out first. So AgCl will precipitate out first.